like uh, till today, what we have seen, maybe in just 5 minutes. In session one, actually, we saw some theoretical portion about CAE, variety of solving methods, numerical method, experimental method, even like analytical method. Then we have seen what CAE means, even some differentiation points between CAD and CAE. So yeah, we have seen variety of examples also. Afterwards, we have solved some beam problems, simply supported beams, or basically 1D elements we solved. And yesterday we solved 3D element problems, so which has like 3D like structure in 3 dimensions, and we extracted results in 3 dimensions. For example, like total deformation and equivalent stress. Today, we are going to see buckling. So, can anybody tell me like what is meant by buckling? If you come across this word during this tenure of your engineering, if anybody can tell. If not, like you don't know, also you can directly tell me like you don't know what is meant by buckling. Then I'll come to know like till what extent I need to go. So, can anybody tell me like what is meant by buckling? You can anybody can simply unmute himself and can tell me. Anybody?
Bending due to compressive forces, sir.
Right, right. Perfect. Bending due to compressive force. Yes. So here, do we consider a length of the part, so which is in compression? Hmm? So you must know that like a famous bending formula just to calculate some eigenvalue vectors. So it includes some length part also. So yeah, we will see it into depth in depth. So this is a like I'll say guideline or something, not guideline but informative presentations shared by Ansys itself. You can just simply type buckling and Ansys and you can get this PPT available online. So on Google also you can search this, you can easily get it. So no need to search for this PPT. uh, so here I can explain what is meant by buckling. Buckling is nothing but like structural instability. Means maybe I'll quickly go to the stress strain curve. Maybe if I have it mentioned over here, let's see. Yeah, here I have. So you can see my cursor, right? Uh, you can see my cursor because
Yes,
it's
sir.
important. Okay. So basically, my stress strain curve is like something like this and this. So it starts from like origin, it goes until this point. Here my yielding occurs. Then again it goes like something somewhat like horizontally, and it will break. So something like that. So that's my general stress strain curve for ductile materials. Here actually what happens in buckling, as I increase my load, up to certain point again it follows my laws of elasticity, so whatever my elastic materials are following, after that its stiffness suddenly goes off, means it behaves like my structure do not have any stiffness. So maybe somewhat mentioned over here, yeah, at some point there is loss in the stiffness followed by a rapid drop to negative stiffness. So it behaves like my structure do not have that amount of stiffness. That's why what is happening, see my amount of load is goes on below. So this is my load and this is my deformation, right? So it goes on decreasing, and after that suddenly it regains its stiffness, so suddenly it get back its resistance, and again it goes to the same point, maybe I can say the same state where it was previously. So this behavior is nothing but my buckling. You understood this because maybe I can explain it again. In our uh, what I say, ductile materials, what happens uh, as I increase the load, my body deforms, and afterwards it starts like neck formation, and that after that it just breaks. So that's my general code. But here, what happens as I'm increasing load? Here, actually, the basic difference is my load is in compressive direction. But yes, my stress strain curve also behaves in a similar fashion for compressive load also, right? Here what happens after some point, there is a loss of stiffness, that's why it just drops down, and again afterwards again it regains its original what I'll say resistance, so it goes back. So that's simple difference between the buckling and our general day-to-day life loading situations. So some examples are here. So as I already said, like uh, that length part is also important. But here, if you can see in one of the example, here it has shown this Coke can, this soda can. This is also one example of buckling because here also there is sudden loss of stiffness. That's why this is unstable. You can see this part, like maybe if you assume that if we have x, y, and z axis over here, then if I am just tracing it in z axis, you can see the behavior of this body in x and y axis direction. So this is nothing but instability. So that's why this comes under the buckling. Again, this rail tracks, due to my what I'll say, the tensile loads. Maybe if I am having some loads in this axis, like in this axial direction of rails, so what it tries to deform like in such a manner. So this is also nothing but one example of buckling. So so we just has like that impression, means if this buckling words comes to our mind, then what comes directly in our mind is like one beam with some height, and it has some load from its top, that to compressive load. But here with these examples you can say, so these are also some examples of buckling, right? Again, there are again some types of buckling like local buckling versus buckling. Uh, what it is saying, just let me read it out. In buckling, structure loses majority of stiffness and can no longer support the load. Okay. Local buckling loses portion of stiffness, but overall it can still support the load. Okay. So what happens in local buckling? It loses the portion of stiffness, but it can withstand and support the load. But it will not fail. It can withstand, but with some change in its shape. Maybe it buckles, it deforms in some direction, and it will support. But in case of buckling, what happens? Majority of its stiffness loss happens, and it can no longer support the load. So it just simply breaks down. So same thing here. We have the buckling equation. So as we have seen in our first session, that our numerical methods, they follow these famous equations. So here this term is nothing but my potential energy, and this term is nothing but my kinetic energy. So again, same thing. It is solving the same. My stiffness into my deformation is equal to my load. So this formula it is solving. Yeah. So now in this slide, I can tell you this is nothing but my column. So which is having a comparable height than its cross section, which is fixed in the bottom part. And if I am applying a load, it can deform either in two directions, maybe in the direction mentioned in one, or it can deform in this direction. Means, and for time being, what I'll call it as like mode shape for time being. We will go into this terminology afterwards. So it can follow mode shape towards one, or it can follow mode shape towards two. So I can't predict, means in which direction it will go into deform, or it will go into buckle. Buckle is the best word or correct word, I'll say, rather than deformation here. So we will come to know like how we can know in which direction it is going to buckle. So Again, this point is called actually bifurcation points, means at the load if I am applying and if I am having such condition. So this condition is nothing but my bifurcation point condition. So at which I have like more than one direction, like either my column can buckle in direction one or two. So there are again some techniques available to solve this. And again, my main concern is I need to know until what load it will support my structure. Like maybe if my force is let's assume like 1000 kilonewton. If at 1000 kilonewton my structure will become like this and can sustain the weight, means if it comes under my local buckling, or if under this much load it directly breaks. So I need to know that also, right? Means what at what till what load my structure can sustain that load. So that I need to find out. Uh, Again, here we have already seen this. So same thing. I think it has explained over here. So just uh, differentiated between general stress strain curve and this curve, right? Again, we have variety of analysis available in Ansys, like linear eigenvalue analysis, non-linear and transient analysis. So what actually difference is the linear is the one we had solved, like we have solved the problems for the horizontal beams and even like yesterday for 3D structures. So same problems we will solve, those will come under the linear eigenvalue analysis. In non-linear buckling analysis, what it will come, there we will define like non-linear material properties. So and even like non-linear loading conditions also. So it will come under like non-linear buckling analysis. In transient analysis, we will give the loading with respect to time. Like my loading will change according to my time steps. So it will come under this transient analysis. But for time being, like for today, we will just stick to this linear eigenvalue analysis, right? Again, yeah, depending on to the objective, like what you want, there are variety of calculations available. uh, Again, yeah, this is main terminology you need to know. uh, this is nothing but my load multiplier. So you can see from this equation, k plus lambda in bracket s. Just don't go into that equation. I just want to let you know this load multiplier. So this load multiplier is nothing but, maybe if I'm having some column, so this one, and by calculation I came to know it can withstand like 1000 kilonewton load. So that's fine, 1000 kilonewton load this can withstand. But now if I am calculating this column for 100 kilonewton, what I'm calculating, I'm calculating this column for 100 kilonewton load, this force 100 kilonewton. Then at the end I should know, like if I am increasing that 100 kilonewton to 200, 300, then at what limit it will go, means I don't know, currently I don't know that it can withstand 1000 kilonewton, but I need to know till what load my column can sustain. So my current load is 100 kilonewton and my limit is 1000 kilonewton, but I don't know that the limit is like 1000 kilonewton. So here my multiplying factor is 10. So my current load is 100, and if I multiply that 100 by 10, then my total load will be 1000 kilonewton, right? So that is nothing but my load multiplier factor, means I came to know till what load I can increase it and my structure can sustain that. Got it? Or maybe I will explain it again. My current load, if it is 100 kilonewton, and I need to know till what load it is going to withstand. And if my calculation results gives me that my load factor is 10, then 100 into 10, 1000. So until till 1000 kilonewton, my structure can withstand that load. Correct. So same things here it has mentioned. Again, not only this factor like load multiplier, along with that I am interested in its shape also, like in which direction it is buckling. So that shape, I already said it is called as mode shape. So I am also interested in that shape. So we will at the end of the this calculation, buckling calculation, I come to know about this mode shape also. Right. So these are some general statements. So you can also go through this presentation. You can simply go to the Google and you can type buckling answers. You can get this PDF easily available. Same things they have mentioned. Okay. So I think yes, you have got overall idea about the buckling now. Now let's just move to our calculations. So first of all, we will solve one problem for this, what it is called as. This is, I think, 1D tower. So this is nothing but the towers we generally see, like high voltage line towers, somewhat like that. So we have some portions fixed on the ground, and again on the top we have some insulators and some electric wires. Those are mounted on that. So like that, this structure is. Maybe we will go to the Ansys and let's first try to solve this with the help of buckling. So what I will do now, I'll just go to the workbench. Just go into the start menu and type just workbench. Here, let's first read out what input data we have. Here, material should be of structural steel. Force, it should be acting in downward direction. And here they have mentioned in Z axis. Constraint should be four base vertices, means these 4 points at the base, and maximum modes to find two. So we need to find two modes. So as we saw, maybe here, yes. So such modes, one, two. So these modes we need to find up to two modes. We can still find more number of modes like three, four, five, but it will consume my analysis time. So my analysis time will go on if I'm increasing this number, like while solving my calculation, right? And I at the end, what output I need? Buckling mode, mode shapes, and load multiplier. So same thing. I need to know these two mode shapes and load multipliers for these two modes. Fine. So now my mechanical window is open. First of all, what I will do, I will just go to the file. I'll say save. So I'll simply define any library directory, and there I'll just maybe type session number 4 and say save. Okay. So here maybe I can tell you. So here, this is nothing but load, and these are my constraints. So I can solve this problem by simple way of static structural, right? Just apply 100 kilonewton and just constrain these 4 points. Just addition here is these two, like mode shapes, finding mode shapes, and my load multiplier. So here actually I will need to define two different analysis. So first system I should need to define is static structural, where I'll need to add loads and constraints. And second I need to define is the eigenvalue buckling. Here we have it. So let's first complete this static structural portion. So I'll check the material. Material is structural steel. So I'll not go into the engineering data because we already have that as a default material. So afterwards, I'll go with the design modeler. Just right click on the geometry and go to the design modeler. So my design modeler window will be opening. Let's just check the count again. Okay, 11 we are. Fine. Okay, now we are into the design modeler. Let's just check the units, convert it to millimeters. Fine. Now, actually, I have this file saved. So this is in the format of maybe IGS format. I'm having it. So which was created in SolidWorks. So I will simply import that file now. Maybe before that, I'll simply click on one of the plane. So currently, I have selected XY plane and go to the files, and I'll say import external geometry file. Okay. So here I have imported okay. Now our question is with 1D tower. I'll go with the 1D tower. Fine. So all are that IGS format. You can see the type over here, IGES format. I'll say import. Let's check what I'm importing. Is no, but I simply it is by default saying yes. But for line bodies, it is saying no. But here I only have line bodies. That's why I need to make it S. If I don't make it S, let's see what happens. I simply generate it. It will give me this error. So I kind of sign. See the red exclamatory mark over here. So this is not correct. So what I will do again, I will right click and say edit, and here line bodies. I want to have line bodies because I only have line bodies in my saved file. I know that. So I do not have any surface bodies. I do not have solid bodies. I can just make them no. That's fine. So whatever I want, I just simply say S over here. So yeah, you can see. I think I have imported the wrong model. Let's just try to go back and try to import this one. So what I did, you checked, I simply go onto the source. On that three dots I checked. So I directly redirected to the the file I imported. So I do not want this one. Now I want this one, the second one. So I said open, and now it is already saying line bodies as I want to import line bodies, and say generate. Yes. So now we have imported the correct model. You can see all the lines, right? So all the lines and even small steps which I had during the preparation, it was in SolidWorks. So those were present over there. Fine. Now here I can see the line bodies. If I just click on that, maybe you can see it in red color. So now the only point here that I need to define the cross section for these lines, because this Ansys cannot consider any cross section for this. For Ansys, these are only lines, but I need to define some cross section for it. So go to concept and add cross section. Maybe if we have such towers available, so maybe we have that
Sir,
L sections, right?
sir,
These are
actually,
generally
can you
sorry.
repeat how you generated this tower again, sir?
Okay, I can repeat it. Maybe simply I'll go back. Uh, so geometry. So just open the geometry portion, right? So just double click on this because I have already opened it somewhere over here. So let's just delete these two commands. Maybe here. Fine. So I'm from. I'll do everything from start. First of all, I'll select any plane, so onto which I need to import my file. So I have selected this XY plane, right? Just go on to the files and say import external geometry. So earlier what I did, I imported this one, but after importing, I came to know that this is wrong file I imported. So I need to import this one. So just click on that file. So these are files actually created by using SolidWorks and saved in this format, like IGS format, right? And these are all line bodies. So I'll say just open. Now, during import, Here I have to click some options like whether I need to import solid body, surface body, line body, simplified geometry, or like simplified topology. I will not go into other options currently. Just concentrate on these three parts: solid, surface, and line. So line means 1D, surface means 2D, solid means 3D. Right. So what I have in my model that I know, I have only line bodies. So I need to just say here S. I do not have any surface and solid bodies in my model. So I just neglect this. If I keep it as also, it will not affect my end result. And if I click it as no also, because I do not have any surface or solid body available in my model. So that doesn't matter what I tick over here. But the only important point is for line bodies, I need to click S. So right click and say generate. So as I generated it, so you can see I have this tower. Now I'm having only lines of this. So if you can see over here, so they all have lines, but here you can see cross section, and it is what it is saying. It is saying that not selected means I have not yet defined the cross section for these lines. So my first part should be to define the cross section. So you know that like how we define the cross section, just go into this concept in cross section and add the cross section. So generally these towers of we call it as like L section, so or L angle we call it as. So these columns are made up of this L size of angles. So this one we had. Again, here I'll just go with the standard dimension of 10 by 10 millimeter and 1 millimeter thick. Maybe we can increase slightly its thickness. So I made it a little bit thicker, 2 millimeters and 10 by 10 size. Fine. Now my next part should be to apply this cross section to all the bodies. Maybe here I can have some members which will be having maybe some different geometry. Maybe this top member. Let's go onto this. Maybe I can just simply go from this part also. Go to the body. What I did, I selected this one by using this line selection filter. Just right click on that and just set go to the body. So what it will go, it will directly means it will redirect me to that body. So there also I can have maybe some different cross section. So what I need to do, I need to go on to the cross section again, and I need to say maybe a circular section. So find circular section of 10 millimeters. So what it is, so maybe the only one member is having a cross section of circular and all others will be having L shape. So that also I can do, but currently I'm not going to do that. I'm just using oh, it is saying me that you have already assigned it to some you have used it somewhere, so you cannot delete it. So what I do, I just remove it and then I delete it. Fine. uh, so what I will do now, I will simply select this one. I will press shift and I will select this one. So what this happens, it got like everything is selected. Or else I can just simply press control and like click all the bodies. So these are the ways of selection. So if you want to select by using control key, just hold the control key and click all the bodies you want to select, or just click this, press shift button and press the last one, so everything in between will be selected. Fine. So cross section I need to define it to L2. So I have defined all the cross. Oh no, I haven't yet defined, because for last only we have defined. So let's just define like this. So with this yellow line, now you can see, say, my cross sections are assigned. Fine. Now, here actually the only change with respect to our earlier calculations is here we have now number of parts. So whatever until now we have done or we have calculated for only one part, like we deal with only one part. But now I'm having around 12 parts or 12 bodies I'm having. right? So currently Ansys do not know that these two bodies are attached together, maybe somewhere here. In reality, they are welded to each other, right? But how come this Ansys know that all these four bodies are merged at the single point or welded at single point? So for that, what I need to do, maybe somewhat, what was that? The other. Okay, so nothing. It was just simply, I think. So I was just telling, how come ANSYS know that these are all like maybe five bodies are connected at a single point. Currently for ANSYS, these are all separate bodies. So what I need to do, I need to do this addition, like just say select all the bodies, right click and say form a new part. What I'm saying, form a new part. So now you can see what changed over here. Earlier it was 12 parts, 12 bodies. Now it's one part, and in that one part, I'm having 12 bodies. So I'll do it again. So I'll explode it. Here you can see I'm having 12 parts, 12 different parts, and 12 bodies, nothing but the same parts. So for ANSYS, it is having like this is one, and they are all separate. They are not connected to each other. So to have connection in between those, so to have connection among all those, what I need to do, I need to just right click and say form a new part. Now I'm having only one part, and in that part I'm having 12 bodies. And here you can see shared topology method is my edge joint. So what is sharing in between these all? So you can see. So all these five have now same color and all are like, so this point is nothing but my shared point by all these five members. Correct. Now you got it why I did this. Any question until now? So if you come to know this, then everything like from this point onwards is easier to understand. So until now, everything is clear to everybody. So you got it like what I said. So any doubt or anything is there. So until this point, like until application of cross section, we have did in our last session. But today, only difference is I have made them, or I have made them attached to each other. Means what I did, I simply welded them to each other. You can say that in a rough language, not in the reality. But what I did, I just merged them at a single point. Fine. Now, my part over is here in design modeler is done. So I'm having currently one part, and with that one part, I'm having 12 bodies. So now what I'll do, I'll simply go to my project window again, and here I'll just click on my model so that I can just enter it into the mechanical window. So in mechanical, in the pre-processing part, here I will have to carry out its meshing, and even in setup I need to carry out like I need to add some boundary conditions. Fine. So I am into the mechanical now. Just check units. Everything is fine. Just check cross section what we have defined 10 by 10 into 2 millimeter thickness. That's fine. So now here you can see I have all the 12 line bodies. I can check its assigned material as structural steel also, and here also you can see that material. If I just simply select this part 12, so not like all other, so simply the group of that bodies. So here also I can see the structural steel. So all the parts having this material, so that's fine for me. So here we already done the grouping into the design modular, so we do not have any need to define contacts separately. I'll simply move to the meshing portion. I'll right click and say uh, update or mesh something. Anybody anything can work over here. In mesh, if I simply go, maybe I'll simply go to, let's check the size. So around 2000 millimeters. Okay, fine. So my part is meshed. Now I'll go to my problem statement. So I need to apply the force on maybe this member, and in that direction negative 100 Newton, and constraint should be these four base points. So uh, basically now I'm having the four corner points, so I'll first select them. So here I'll be applying the constraint. So I have selected by using control button, so just pressed control and selected this one. Or I'm having maybe a shortcut, I'll explain you now. So I just click on the arrow so that my plane will be visible to me. I'm having a box select option available with me. So what this box select option does, so I simply right click and drag, so it will zoom for me. So this box click means from right to left, like from sorry, from left upper corner to right bottom corner. It will select only the portion coming into that box. And if I'm going from like right bottom to left top, so currently I am into this only, what I'll say, vertex selection. That's why it is selecting vertex. If I go into the line selection and then perform same thing, so it will select whatever is coming. Like even if I'm selecting a small portion also, it will select whole part of my body. So that's difference between two-way selections. Maybe left to right. If I'm selecting, so nothing is getting selected, and I'm selecting right to left, so all the members are selected. So you got the difference between these two, like right to left and left to right. So nothing is getting selected while I am dragging from right left to right, because whatever. So now you can see only some portion of member is coming into that box. That's why it is not selecting. But when I'm going right to left, so even if I'm having some portion also, so my whole beam gets selected, right? So that's my box selection. So it will be helpful while applying such boundary conditions. So what I'll do, I'll simply do such thing. So I can drag from anywhere because I am into the point selection. So anything will come in this box will be automatically selected. So I'll simply right click and say fix support. So you can see now my all 4 points are getting fixed. Now, second, my portion is to apply load. Just go on to the line selection, and I'm still into the box selection. Either I can switch it back to single select and select this, or if I am into the box selection, what I'll do, I'll simply move from right to left and select this one. But be very careful during selection of such things, because if my cursor goes from here to here, see what you can see. The other bodies are also selected, so that should not happen. So it's always better to select it with a single click, right? So I have selected this one. Simply go insert and the load. So load I have selected. Now I want to select its direction. So I want to have force in negative z direction. So I should change the method of its, and I should simply select the components. So I need to define the load a component wise, and in z I'll simply add 100. So you can see the arrow, it is popping in upward direction, means it's tensile, but I don't want this. I want it into the downwards direction. So I simply put minus sign over there, and my load is now in negative z direction. Fine. So I have applied the force as 100 Newton. Four base points I have fixed. Now my only aim is to find two modes. So currently I am only solving it for static, so nothing to worry here. So I simply right click and say solve. So whatever we did until now, that's simply a static structural problem. But now what we will going to do from this point onward is for like calculations for buckling or calculations for mode shapes and load multipliers basically. So for that, now what I need to do, I need to go back to my project window. So my this problem has been solved. So what I will do now, I will use this data. Then so I will use whatever we have solved over here. By using this data, I will calculate my buckling. So just go back to the project window, go to the eigenvalue buckling, and here very let's be very careful on this point. So I need to drag this and I need to place over in the solution main box the row number 6. So please be very attentive over here. I should release my mouse click on the solution. So I can drop it anywhere. I can drop it on row 2, row 3, row 4, or maybe row 6. But I'm very clear here. I want to use these results for my buckling analysis calculation. That's why I'm dropping it into the part of solution, because here I'm having in what I'm having in this solution row, I'm having all the data of these calculations, whatever I did in this first 5 rows. Fine. So now this is my coupled calculation now. So I will double click to any of this after model. If I double click on this or this, like 5, 6 or 7, I will again go to same window of mechanical. Or even if I click these three, 5, 6 and 7, I will also end up opening my mechanical window, right? So this is my mechanical window and this is the addition, right? So I'll solve it. So we were somewhere here. So I have solved only the static structural part, and here also you can add if you want. You can add maybe a deformation, or maybe you can add some stress or strain results. But here I am not getting these results because can anybody tell me why I am not getting these results? So I have told this point to you during our last sessions. Maybe you can tell me why these results are not visible to me. You got my point. I am not able. I cannot able to see. Oh shit! What is this? Here it is. Somewhere over here. Okay. I am not able to see my equivalent stresses. Why I am not able to see this? Can anybody tell me? Uh, you need to unmute yourself. I need to know like how attentive you are during these sessions. Uh, why I'm not able to see this equivalent stress? Can anybody tell me? We have did this. We already did this. Hmm? Anybody? So these are very like some pinpoints you need not to miss. Maybe I can tell you. Uh, During solution, we have one option to extract results on my beam section. So it is currently set to no. That's why I'm not able to see the equivalent stress results. If I right click also, I cannot see the results like stress results over here. You can see only deformation results I'm getting. Or from here also, I cannot able to click, right? Only because of this. I haven't selected that I want results on my beam section also. So for that, I need to make it S. So if I changed it to S, in that case, I can simply add equivalent stresses, right? And afterwards, just evaluate. Fine. So I have now those results. See, maybe I have selected very small size like 10 millimeter by 10 millimeter. That's why, because here from the bottom scale you can see I have around 2 meters length. So for that 2 meter length, my cross section size is very small. But yeah, no issues. We will simply calculate this and let's see what results I'm getting. So here you need to check. It is saying pre-stress. Pre-stress means this is my model, and this model has this load and this constraint, right? This load and this constraint. That's why here it is saying pre-stressed. You got the point. Pre-stress means already it is carrying some load, right? Why it is saying pre-stressed? Because just come to this point. So whatever eigenvalue buckling calculations we will do, those we will do on the results obtained from this static structural calculation. Getting my point? That's why it is saying me whatever I am having is pre-stressed, and from where it is taking these results, it is taking results from this static structural window, this static structural. I know this is a little bit difficult to digest at first, but as you practice it, you will get familiar with these concepts. Uh, Fine. So now my only point is to check the number of modes I need to find. So here I'll just go into the analysis settings and I'll see. So maximum modes to find. So by default, it has set it to 2. If I need to add more, then I simply click here, or I can simply select it and I can simply put some numbers, whatever I need to find. Right. So I have set the maximum modes to point to 2, and now my everything model setup is done from my side. Now what I will do, I'll simply right click and say solve, or I'll hit F5 button as a shortcut to solve it. So let's wait. Yes. Now my analysis is solved. I need to add the results in that. So I'll simply right click in insert. In deformation, I'll add maybe a total deformation. I'll simply evaluate it. So this is nothing but the deformation. You can see, let's check the force in the Z direction. Fine. So this is nothing but my total deformation. If I add directional deformation, and direction is Z because I applied load in Z direction, I am interested in Z axis direction. Okay. So it is giving me strange results. So it is simply deforming in this y-axis direction because I am having very small cross section as compared to my all lengths. Fine. Now, uh, what results I am interested? First is mode shape, and second is load multiplier. So these are nothing but some additions I just find out, like total deformations. So simply go click on the solution part, and here in tabular data you can find out load multiplier, right? So for 1 and for 2, so I'm having currently two steps. So at first step I'm having zero load, so there I am having negative load multiplier factor, and in this two load step, so I'm having a force of 100 newton. So I can show you the force. So I'm having two steps. By default it is step 1. So in first one I'm having 0, and in second one I'm having minus 100, so 100 newton. So same thing will be same results I'm getting. So first one is just means a starting point. For every analysis you need to start from somewhere. So it itself considers, software itself consider a 0 point. So zero load, zero whatever it is. So we are not interested in this, so we are only interested in this point, so where I have this 100 newton load applied. So what I will do, I'll simply tick over here, so on this box. So what will happen after that, my both the columns will be selected. So just check it again maybe. So click on this part. So the portion between the rows and columns. If I click over here, my whole table gets selected. Afterwards, what I need to do, I just need to right click somewhere. So at any point, you can right click. And second option is create mode shape results. So you can simply click this. So what happened, you see here, I have two different mode shape results. So here you can see mode number 2, mode number 1, total deformation for mode number 1 and mode number 2. So even you can just simply go with this total deformation also. So here also, from here you can change, but by this you can have the same. Maybe I can delete it again just to avoid your confusions. I'll click on solution. I will click on the modes. I'll select this table. I'll right click and say create mode shapes. So I'm having for mode shape 1 and mode shape 2. Simply right click and say evaluate. So this is result for mode shape 1. So in first mode, my this part is buckling in y direction. In mode shape 2, with that, my even some bottom beams, like bottom members, they are also slightly buckling in this negative y direction, right? And here I am having a load multiplier, you can see 2.7 times. So in mode shape 2, currently I am having 100 Newton load, but I can increase it to 2.7, and even though my structure will not collapse, but it can sustain my load with some buckling. With having some buckling, it will sustain my load. What this? Maybe I'll solve this problem again to have maybe good clarity, because here whatever cross section I have assumed, it is very small as compared to my length. Maybe I can zoom it and show it to you. So maybe any single member I'll, yes. So I have simply say hide all other members. So you can see I'll just go to the here and say undeformed. Just to check that, I need to right click and zoom. So this is very small as compared to my length. You can see length of my this portion here from bottom ruler, you can see. So in the range of 2 meters and 10 millimeters I'm defining, that's very small. Maybe I can go back to the my cross section, and I can simply say maybe 50. Oh, here also 50, and maybe thickness I'll say 10 millimeters. Fine. So I'm having 50 by 50 cross section. Now everything what I did until now will got like symbols like this. What it is saying? It is saying me it's like results are there, but as I have changed some data from upstream, maybe upstream of this, like upstream of the row number 4 is row number 3. I have changed some data from row number 3. That's why I need a rerun. So that symbol indicates that a green tick with some yellow mark, green tick with yellow arrow, like showing upward direction, says that you have changed something in upward rows. That's why you need a rerun. Fine. So what I do now, instead of like right click and say solve over here or update over here, I have one option in the project window. See, update project. What it will do, it will update everything available in this window. Maybe now I am having A and B two systems, but if I'm having 4 or 5 more systems also, with this option it will solve all the systems available in this window. Or else I'm having other option also, just go here. So here you can see they are not yet updated because I haven't clicked over here. So if I click in on this model, what it is saying, upstream data needs to be reread. Would you read the upstream data? So what it is saying, this data need to reread again because you have changed something. So I'll just say S, as we have changed the cross section size or cross section dimension. That's why this is happening, right? So my mesh has gone, my calculation results has gone, so everything has gone. So I can simply click over here, generate mesh, click over here, say solve. So this can also work. And other option is from home window, just click on update. Fine. So let's try with this option now. So I simply click this update project option. Let's check what is happening here. So it has meshed my part, and now it is solving for the static structural portion. So this solve is done, and now it is solving for my buckling portion. So you can see here it is solving. You can see some green or yellow mark. So it says it is solving. Done. So my solve is complete now. So just go to the results and check. Okay, now I'm having like the good results, because earlier I had like the strange results because of my member size. I have defined very small. Fine. So I'll simply right click and say show all bodies. So here you can see, so it is having in y direction, right? But I have increased its size from 10 millimeters to 15 millimeters, 50 millimeters. I had like earlier load multiplier factor around 3, 2.8 or 2.7 something. Now I am having load multiplier factor as 1621. Means I can increase this 100 Newton load to 1600 times, 1621 times. So can you imagine what load it is? Let's just check it. 1621 times this load. So can you say like 162 kilonewtons load? I can go up to that much load. So from 100 Newton, right? So that's nothing but my load multiplying factor. So my structure can withstand this much load. So as here I'm having very small load, that's why it is giving me such results. Maybe just go to the reality. Just maybe I'll shift it to 100 kilonewton. So instead of Newton, now I enter 100 kilonewton load, and I simply say right click and say solve. So if I say solve for this buckling, then automatically my all the upstream things, so whatever before this will solve. So what I did, I just simply changed my load to 100 kilonewton instead of 100 Newton, just to check what mode shape results I am having. Yes, so I'm having good results over here. So 1.17 millimeters as a deformation, and my load multiplier factor is 1.62. Means I'm having a load of 100 kilonewtons, and I can go up to this much limit, 1.62 times, right? So same thing, so 1.62 times. So in the results, you can say I'm having mode shape. So what it is saying me that my this tower, it is deforming in the y direction. So this is shown by my mode. So in the both modes, like mode number 1 and mode number 2, in both modes, my these beams, they are deforming in this y direction. And second one is the load multiplier. 1.62 means currently if I'm having 100 kilonewton load on this, but I can still go up to this 1.62 factor, right? And with that load can sustain for my this structure. So uh, we got these results. So yes, this is it for the problem one. I think we have more time. We can go to the other problem also. I think let's just go to the this problem. So here also we are having a similar kind of tower, or we can solve this spring also. These are small, uh, or even we can solve this. So let's just go to this one. Problem number 5. We will solve this. So again, same things we have. So maybe I'll save it again because whatever changes we did. Now, so just read out the whatever input data I'm having over here. So again, material, it's a structural steel. Force again acting into the downward direction, and the same one, maybe 10 kilonewton load, that too in y-axis. Constant should be the 4 bottom points, and same results I want. Like I want to find maximum 2 modes, and even like mode shapes and load multiplier I want to find out. Okay, so let's just what I'll do, I'll close all the parts I have opened earlier, just to, yeah, so that it will be faster for me. Fine, so I'll start with static structural, drag and drop, or double click, both can work over here. Fine, so I'll not go into the engineering data as my structural steel material is defined, already defined. So I'll simply go to the geometry and say design model. Here I will import the model. So the model for 1D radio tower, I will select the plane. So I want my model to be placed on this plane. I'll go to the files, and here I'll say import external geometry file. And here I'm having that radio tower. Fine. And then I'll just say generate. Can I see it? No, because I haven't clicked what I want to import. So here basically my line bodies, I'm saying no, means I don't want to import line bodies. That's why I'm not seeing anything and I'm getting this error. So I'll just simply cross it and say as. So right click and generate again, and just click on to this one. Fine. Can you see now? So I actually forgot to set my units to millimeter. That's why it is showing very small. But yeah, now you can see it. If I just click on to fit to window, then I can see this. Fine. So my first part is done. I'm having 48 parts or 48 bodies available with me, and they are all separate. So they are not connected to each other. So now what I need to do, I need to first define the cross section. I'll go to the concept and I'll simply say cross section. So this time I will use something different, some different cross section I will use. Maybe just go ahead with this channel section. Let's use this. I'll use the channel cross section, and yeah, maybe instead of 10, or let's go with the default one. But yeah, it's very small as we already seen in our previous calculation. Maybe I will go with the 25. 25, 25, and this one should be 50. And here I'll simply say 5 millimeters. Fine. So this is nothing but cross section of my C channel. Okay. Now I have defined the cross section. Now I just need to define this cross section to all the bodies. So just click the first body, press shift, click the last body, and say channel. So I have defined cross section to all the bodies. So my all bodies are with cross section C. Fine. Now again same thing I will do. Now I have defined cross section, but my all these parts are separate. So I need to merge these parts, or I need to merge the end points. So these points, if I can see that those points are coincident, but Ansys doesn't know that they are welded or they are connected to each other. So this is only like visible to me. They are connected, but for Ansys they are separate. So what I need to do, I need to just select all bodies, say right click and say form a new part. So what I'm doing over here, I'm sharing like topology at the edge points. So these points are now connected. Now you can see everything is in yellow color. So for Ansys now they are connected at this point, right? So my part here in design modeler is complete now. I'll move on to the other portion. Just click on this model so that I will be into the mechanical window. So just double click on this and wait that our mechanical window will pop up now. Okay, fine. We are now into the mechanical, and yeah, I have this uh, tower also. Just check the cross section. Okay, I'm having the same 25, 25, 50. Before that, just check units. My units are also fine. Check the material. Yeah, my assigned material is structural steel. Otherwise, I can simply check over here also. I select all the bodies by using shift button, and my assignment is structural steel. So both ways I can check. So I am done with my material. My cross section is fine, and connections, no need to define the connections as I have already merged those bodies in my design modeler by using grouping command, right, by making them into a single part. So I'll go to the meshing. I'll say right click and say generate mesh. Oh, you can see how it is. So now what mistake we have made? Can anybody tell me like what mistake we have made? The same one like we did in our last calculation. I need to go to this one. Yes. So what I need to do? Can you see this? So something is going into each other. So we had one tower and everything is now going into each other. So what caused this and what we need to do over here? Can anyone tell? Maybe I can just open these two windows side by side so that you can come to know. Yes. So what would have caused this? Can anybody tell me? Hmm? Praveen, can you tell me? Hmm? Can you tell me what would have happened this? Like what we did, that's why it is happening? Or what we need to do to resolve this? You can see this ruler, like here you can see I'm having 80 millimeters. So the distance between the 2 points, bottom points, is only 100 millimeters. Now, so it's just hint to you. What would have caused this? Can you tell? Can you tell me? I can't see that. Mm-hmm. No, not units, but the yes, but whatever we have defined here, maybe the cross section, it has caused this. What we have defined here, I am having a 50 millimeters length. So what I'm saying, I'm for C channel, I should have this length as 50 millimeters. But in reality, in these 2 points, I am having only 80 millimeter distance. So it's not up to the the fact that I'm having the same model. So maybe I'll go to the standard portion again. Maybe I'll define a 10, 10 or maybe 5, 5 cross section inward. Okay. So it is not allowing me to go below that limit. Simply I will go back to this one. Let's check again. Yeah, now it is allowing me. Fine. So now what I'm doing, I'm simply giving that this length should be 10 millimeter, this should be 5 millimeter, and my thickness should be only 1 millimeter, or let's make it as maybe 2 millimeters. So to have a clear view. Fine. So 10 millimeter, 20, 5 millimeter, and thickness should be 2 millimeters. Now I can see that it will not be like overlapping to each other. So just I'll say S. So I have changed the cross section dimensions. Now I can see good meshed view. Maybe I'll say generate. Now you can see it. Now you can see a good structure, because earlier what we were doing, I'm having a distance of 100 millimeters and I was defining my C part only with the distance of 50. So it was going into the each other. So it is following only like centroid line of these channels. Fine. So here I'm having now I'll just go and check the load. I will apply the load at this vertex and constraint should be all the base points. Fine. So same thing I'll do now. I'll first apply constraints. So I'll go right click, insert and say fit support. I'll go into the box selection. I'll pick, I want to pick vertices. So I'll simply click on one of the axes, right click and drag just to zoom and simply make a box selection, so that here you can see 4 vertices selected. So from here you can confirm that all the 4 vertices are selected. So I simply say yes. So my fixed support has been applied. Now I will go to the top portion. So here I am having my 4 members, 1, 2, 3, 4. Either I can apply loads on these 4 corners, or I can apply loads on these 4 members. Means I can apply load on 4 nodes, or I can apply load on these elements. So both will give me same results. So I'll say force. Oh, here it is. And now I want to apply it on, I'll say lines, and I'll simply go back to single selection instead of box selection. I'll select all the lines. So basically it is same as selecting all corner 4 nodes. Fine. So for edges it is saying, because I have selected edges over here, and now I will apply the load of 10,000 Newton. Basically 10 kilonewton in negative y direction. So instead of vector I will click, I'll double click and say components, and in y direction I'll say 10 kilonewton load. Right. So my force I have applied constraint also. Now I can solve this. Right click and say solve. Okay. So my model it is solving. Here I can insert the results for deformation, and same thing again I have missed over here. I cannot able to add equivalent stresses. Can anybody tell me now? So same question I asked you during our last or previous calculation, and now also. So why I'm not able to see the equivalent stresses? Can you tell me? Maybe I will pick now some other guy. Can you tell me why it is happening? Or maybe you. Can you tell me why I'm not able to see these equivalent stresses, or why I cannot extract results for these stresses? So I have already added total deformation, but stresses I'm not getting. Why? Vimal Raj? or anybody can tell. If you know, you can tell me. I'm not getting the results for equivalent stresses. Simply, maybe tell you. So in the solution, I have not said that I want results on the beam section. So I need to click it to S, then I will see these stress results. Fine. So I'll say evaluate. And yeah, with that load, you can see how come I'm having equivalent stress and like my deformation. So yeah, it is already deforming with my load. You can see it. Now, we have done with static structural calculations. Now I have to add the buckling calculation into this. So I will use these results for buckling calculation. So what I will do over here, I will simply drag this buckling and I will drop it to this solution. So row number 6. Fine. So now I will double click on any of this row like below the model and I can enter into the mechanical. So here just check I'm having pre-stress, so I will use the pre-stress model from static structural, and in analysis setting I have set maximum modes to point to 2. Fine. So I will get 2 mode shapes at the end. So that's it. So just right click and say solve. So it will first solve for my static structural problem and then it will solve for my buckling problem. Okay, it has solved. Now just click on to the solution part and here I'm having load multipliers. So just click on just to select my rows and column. Right click and say create mode results. So here I'm having mode shapes. So you can see this is my first mode. You can simply select any axis so that your plane will be visible to you. So this is my mode 1. You can see in mode 1 it is deforming in such a way, and this is mode 2. So in mode 2 my other members, they are deforming and I'm getting the load factor as 11. So uh, with this load I can go up to this 11 factor 11.094. Fine. So that's nothing but my load multiplier factor. So we got the buckling mode shapes and we got the load multiplier. Fine. So I think we have done for the this problem also. So any question until now? So I'll quickly take your questions. Maybe I'll unpin you again. Can anybody do anybody have any question? If you have, you can ask me now. Anybody has any question? Anything related to maybe today's calculations or maybe yesterday or day before yesterday's session? Hmm? So I think everything is understood, right? So this silence means either everything is understood or nothing has understood. So I'll assume in a positive way, so you understood everything. Fine. So still we are having some time left. Maybe we will solve one more problem. So I think let's solve this 1D problem. But in this, I think you need to guide me then. Today, actually, nobody from your side has given me some answers. So except I think this guy. So he told me something, but no other than this one really participated today. So who will guide me? Maybe you. Can you guide me for the next problem? So the two problems we have solved, and maybe I will pick the very similar problem. Maybe we will pick this one, problem statement number 2, and we will solve this. So will you guide me to solve this? I, unfortunately, I can't take your name because I'm not able to see your name over here. But yeah, as I have like tagged you over here, can you guide me? Hmm? Or anybody else who wants like voluntary to guide me? You? F053. So maybe from next session onwards, I will request Ajay that you should dictate names over here so that I can simply call by your name. Okay, you can unmute yourself and can you guide me? Hmm? Who? Am I audible? Hello? Okay. Okay, thanks for clearing me that I'm audible, but I'm not able to reach up to this fellow because he's not responding. Uh, or anybody else can. So there is nothing to worry. Means if you are wrong, also I'm there to clear you. So it will only build up some confidence in you, so whether you understood it or not. So it's for you. So can you guide me? So I'll simply follow your steps. You will simply say me like this to do and this to do, and I will follow you, and we will solve the next problem. Hmm? I can see only this person is very attentive in my class from day one. So maybe at the end of this all sessions, I will have to give some gifts then to some attentive guys and who are taking this class seriously. So the can you unmute yourself? 21F053. I unfortunately I am not able to take your name, but can you unmute yourself? Or maybe till then I'll simply start. If you want, in meanwhile, you can tell me like how to proceed. So I'll simply read out the problem statement now. We have the same static structural steel material. uh, Force acting is like 100 newtons, same thing. And now here we have something different, like we have three base points. And same thing, we need to find out like maximum modes 2 and buckling mode shapes and load multiplier. That things I need to find out. So I'll go to main window. I will save whatever I did previously. First of all, I will drag and drop static structural menu. So now, engineering data, already I'm having structural steel. So no need to worry, no need to define other materials. Simply right click on geometry and say design modeler. Now we are going to solve this 1D tower problem. So select the plane. Before that, check the units, set it to millimeters. Select the plane on which I need to import. Select files and say import external geometry files. And I want to have this 1D tower. So simply say import But before going to say generate, just click on this line bodies to S, so that my line bodies will be visible. Oh, I think we took wrong model. It's not like 1D. It's this 1D tower structure. Just I simply clicked on these three dots. I again went to the same location and I simply selected that one and said generate. Again, I guess I need to select this line bodies. Fine. So I have that model with me. Simply click on fit to the screen. So this is the model. So where I am having some triangular shape members, they are connected to each other. So now I'm having 24 parts, but I'm not sure if they are connected to each other. Not even Ansys knows that. So what I will do, I'll right click and say form a new part. Now I have connected all these parts. So second part should be to define the cross sections. So I'll go to the cross sections and say this time maybe I'll select circular one. Simply rods I will select. Let's see what happens. So I'll go, maybe that rod will be much more because they are in height of 2 meters. Fine, that's fine. So let's check its section. So 10 millimeters. So maybe I'll make them as 15 millimeters in diameter. Okay. So I'll go to the part. I'll press shift and select all the parts and change it to circular one. Fine. So I have defined cross section to all my parts, and by this I can say if I click over here, they are shared with the edge joint. Basically, these are connected to each other. If I am not making this as a single part, my analysis may not solve because ANSYS can't know that they are connected to each other. Means what ANSYS assumes, this is one body and this is one body, and they are separate from each other. They are not connected here, so it may fly out somewhere. So if I'm applying some load on this body, it may just move from this location to other location and my analysis will not get converged. So these errors may happen because of this. So that's why this step is very important, just to make them as a single part and tell ANSYS that they are connected at these edges. Okay, so now go to the model, so that I'll go into the mechanical window. Okay, now uh, I'll check the material, structural steel. I'll check the cross section. I had defined it. It's fine. I'll simply right click on mesh and say mesh my model. So I'm having such kind of thing. So I think it's reversed. Let it be now. Uh, so this is top side, and these 3 points, they need to be fixed. Fine. So what I need to do, I just need to say insert and say fix support. Go to the box selection, hit vertices. So I need to select only vertex. So I have selected this and I set it as a fixed one. Second one is just application of load. Just go into the selection of edges and go to the single selection and select these three edges. Say apply. Now I want to have load in y-axis direction. So my now y-axis is pointing in downward direction. So it should be positive now, and I will apply 100. So I have applied 100 Newton load. So what it is saying, yes, 100 Newton load. So currently my, here you can see my y-axis. So my y is pointing downwards. That's why I have applied positive load. But my problem statement, it is saying negative one, as I am having my model in vertically upward, like this is reverse direction. That's why I have applied this amount of force. Fine. So I'll go on to this solution. I will simply say S instead of no because I want a beam result. I will insert deformation and I will insert stress, equivalent stress. Fine. So this portion is done. Now what I will do, I will add eigenvalue buckling to the solution. So check where I'm releasing my cursor. I'm releasing it on my row number 6. So, so what will be happening after that? My engineering data will be shared, my geometry will be shared, even my model will be shared. Model means my meshing, it will be shared. And from solution, whatever I will solve and I will get results, those results will be acted as starting point of my buckling analysis. Fine. So you can click from 567 or 567 from C and D. So it will end up opening your mechanical window and it will be common for both now. Okay. So here pre-stressed static structural analysis setting. I can set my maximum modes to 0.22. Maybe this time I'll just select it and say maybe 3 modes we will find out. Let's see what happens. Now just say right click and say solve. Okay, here these are the total deformation for this 100 Newton load which we have applied from the on that edges, and the equivalent stresses. You can see stresses are majorly here, and to the bottom they are almost negligible, so they are very less in amount. Okay, so now I will go here, and now here you can see I have requested for 3 modes. Means here I have set it to 3. That's why I got these 3 different mode shapes. So now I'll right click and say create mode shapes. Okay, so all my mode shapes has created, and I'll simply say evaluate. Let's see, maybe I'll have, okay, so it's reverse, that's why maybe I can simply say stick to this one. Okay, and let's see. So this is the mode shape 1. So I cannot see any deformation, just I'll scale it up. Okay, so you can see it is moving in X direction little bit, or I can set it some factor, maybe simply select everything and type out over here maybe 100, so maybe 1000 or maybe 2000. So you can see it is reflecting in this direction. So mode number 2, it is again deflecting more. Mode number 3, so it is deflecting somewhat like this. So these are 3 modes I found out from my calculation, and you can check the load multipliers. So these are in the range of 1000. So load multiplier for mode number 1 is 1320. For 2 it's around 3000, and for mode shape 3 it is around 5000. Okay, so let's check by changing the load. Maybe currently if I'm having 100 Newton, let's check with maybe 10,000 or 10 kilonewton. Let's see what happens with my load multiplier factor. Currently, just remember this, around 3,000 and 5,000 for 2 and 3 modes. Let's just solve it again. So what multiplying factors we get, we can check it out by simply changing the loads. Okay, so we are done. So here you can see now I'm having load multiplier factor as 29, and for mode shape 3 I'm having it around 50. So from 3000 to 29 and from 5000 to 51. So by increasing the force from 100 Newton to maybe 10,000 Newton, right? So now you can compare like how we did these three calculations and what basic changes were there, and with the increase or decrease in this force, how my load multiplier changes, and whether you found out like any change in my modes. So my modes are exactly similar to what I had previously. So only with change in my load, I'm having change in my load multiplier. Fine. So I think that's done. Uh, we have completed this problem also. So anybody has any question, you can ask me now. So we are to the last 10 minutes of today's session. So if you have any question, you can ask me now, so I can solve it. And meanwhile, I'll simply just open what we will going to see tomorrow. So anybody has any question? You guys are really very shy. So the batch earlier to you was yeah, they were asking a lot of questions, and I like the questions. If you are asking me questions, then I really appreciate the questions. You should get you should grab these opportunities. If you are asked to ask questions, then you should ask whatever comes to your mind. So, so doubts get resolved at such points or initial points. They are good. So for tomorrow's session, we have nonlinear analysis. So modal analysis is a base of nonlinear analysis. So tomorrow we will see modal analysis for maybe four horseshoe fork. It is knuckle of vehicle. So we will have the modal analysis, even some bridge kind of thing. Again, wheel of a hub or maybe some rim kind of thing, and also one gear. So yes, tomorrow's session also will be interesting. In the modal analysis, we will find out the frequency, or I'll say natural frequency, and even the mode shapes. Because these mode shapes are a little bit different. These mode shapes are because of its natural frequency, or maybe I'll say a body without loading. So, and today what modes we have seen, they are because of my buckling loads. Fine. Okay. So anybody has any question? So tomorrow's session will be interesting, and yeah, model calculations. Those are uh, I'll say the requirement of model calculation is very much in the day-to-day life, or maybe industry, or day-to-day inventions, because every machine needs to be tested for its what I'll say natural frequency, just to avoid resonance condition. That's why these modal calculations are very much required in day-to-day or industry calculations, or whatever new developments. So tomorrow's session will be important. Don't miss tomorrow's session. Uh, yes, so I assume that nobody has any question and you understood everything from today's session. Okay, then I think we will stop over here. Uh, I wish you a good night, and yeah, see you tomorrow again. Bye bye. Thank you. Thank you.